Hello and welcome to this video titled Congestion Avoidance with Policing and Shaping. In this video, I'm going to cover an overview of what is meant by the term or phrase congestion avoidance. And by the time we're done with this video, you'll understand what these terms mean of policing, shaping, and markdown. And then I'll compare the differences between policing and shaping. So what is congestion avoidance? So we know that the whole reason why we need quality of service in the first place is to deal with links that are congested. If there was no congestion anywhere in any interface, we wouldn't need QoS. And as soon as a packet came in, it'd go right out, it wouldn't delay, it wouldn't be dropped, we'd have no problems. But the problem is there is congestion in networks, and unfortunately a lot of times you don't know where that congestion is going to be. So congestion avoidance is really talking about, it's a general term used to define a set of features that attempt to prevent queues from becoming congested. So this is our overall objective here, is that if I have a situation like this, where I have a whole bunch of input ports, maybe these are ports leading to hosts, maybe ports leading to other parts of my network, they're all coming into this device, and all the traffic that's coming in those ports is being funneled out one egress port. Well, this egress port might get congested because it just can't put those things out on the wire fast enough. And if I allow all those things to be directed to this egress port, and these are my memory buffers right here, those memory buffers could get full. And then I have no choice but to start dropping packets because I got no place left to put them. So congestion avoidance, like it says, is a bunch of features that say, hey, you know what? Let's try to stop these packets, or maybe some of these packets, from getting into this queue in the first place, maybe the low priority, the stuff that's of lesser importance to us, to always make sure there's some room in that queue for the higher priority stuff. And that's what we're talking about right here. So where would you do this? Well, there's three general places depending on your platform and depending on what architecture you have that will allow you to do this. Number one, we could do it on the ingress interface queue. On the ingress interface queue. So drawing our picture again. If these are all of my ingress ports, and that's my one egress port, well, we know that each one of these ingress ports is also going to have some memory, some queues and buffers for storing things. So one thing we could do is we could say, all right, well, let's monitor that. And if this thing right here for this one port, fast Ethernet 0/1, if that gets above a certain threshold, if that memory gets to like 80% full, let's just start preemptively dropping 1 out of every 10 packets before it even gets in there. Just drop it as it arrives at the switch or router. Or let's maybe delay some of the traffic. You know, normally once it gets into that ingress queue, it'd be looked up in microseconds and then forwarded to the egress queue. Well, let's not do that. Let's take some of those packets and just hold them back for a few milliseconds. Have some artificial delay induced in there to hopefully prevent this guy from getting overwhelmed and congested. So that's performing it at the ingress queue level. Another place, we could actually do it at the forwarding engine. We could say, okay, as the forwarding engine is receiving all these packets for lookup, let's have the forwarding engine count them as they come in, see what kind of rate they're coming in. As long as they come in, you know, above a predefined threshold, like at 5 megabits per second or lower, we'll forward them to the outbound interface and let them go. But if they come in above that threshold, anything that's above that line, we're going to kill them. We're going to drop them. Once again, we're trying to preemptively prevent that egress queue from getting filled up. Now the forwarding engine is doing it, using something called policing. Or technically, we could try to do it at the egress queue itself. This is not a very good way of well, let me pause and take a step back on that. You can do it the egress queue. With the egress queue, what you could say is if this is my switch right here, and here's all my ingress ports, and this is also true of a router too, and this is my egress port where stuff is being transmitted, and this is my memory buffer. Now, in the world of QoS, typically what you would find is that most of your traffic is your default traffic, your low important traffic, like people just browsing the web. You know, that's, if every once in a while that stuff gets dropped, not a big deal. Your high priority traffic is like your voice, okay? But in the scheme of things, if we look at the sum total of all packets going through your network, your voice packets are a small percentage. Your voice packets are maybe like 5% of all the packets going through your network, if that. So keeping that in mind, we could say, well, here's what we're going to do. If we just let everything go about as normal, we didn't touch it, this queue could get potentially filled up. And what would probably fill it? Would it be our voice packets are filling it up? Probably not. It'd be our low important stuff, like people who are doing YouTube or people who are, you know, uploading files to Dropbox or stuff that's not as critical as our voice traffic. So in order to prevent this thing from getting filled to the point when a voice packet does come in, there's no place for it, drop. In order to prevent that, we could actually go to the egress queue and we could say, all right, let's set some thresholds there in the egress queue. Let's tell this egress queue here that, you know, if you get to 40% full, why don't you start dropping maybe 1 out of every 10 frames that comes in? You know, even if you got all this space right here, start dropping 1 out of every 10 frames anyway. And if you get to like 75% full, let's start dropping like 6 out of every 10 frames. You see the objective, the purpose behind this is we're desperately trying to reserve some room so that when a voice packet does come, or whatever it is that you define as being important to you, we have room for it. So we could do it on the egress queue as well to try to prevent the congestion from happening. So those are the 3 different places. Now let's just do some terminology here to wrap up this video: policing, shaping, and markdown. And my objective here in this particular video is not to go into all the gory details of how these features are configured, your various options and gotchas and caveats. That is for a much more advanced level series, and we actually here at INE have a lot of videos that do go into that level of detail. So if after this, after you've been introduced to these features, if you want that type of knowledge, please go back to our website, my.ine.com, and you'll find some more advanced QoS videos that go into that level of detail. So for here, I want to sort of help you define what is meant by these terms: policing, shaping, and markdown. Okay, so this type of thing is, these features are typically implemented between your edge router at the edge of your network and the ISP's router at the other end of that connection. So between you and your service provider, it's providing you internet service. Now, when you set up that connection with your ISP, one of the things they're going to ask you, and this is going to directly affect your monthly bill, is how much speed or how much bandwidth you need. I mean, clearly they might have the capability of running a fiber optic cable to you. They'll give you a 100 gigabits per second. Of course, they're going to charge you like $5,000 a month for something like that. And if you're a company that doesn't need even a fraction of that, why would you pay for that? So they're going to ask you something like, what kind of contracted rate, what kind of committed information rate do you need from us? Because we can run a cable to you that's capable of supporting out of this world speeds. What do you actually need? So you're gonna negotiate that with them and negotiate a contracted rate called a CIR. Now, once that's agreed upon between the two of you, it's up to both of you to enforce that. You see, on their end, for the ISP, they're saying, okay, that customer better not send us any more than what we've agreed to. If we've agreed to a committed information rate of like maybe 100 megabits per second, and they start sending us 300 megabits per second, that's going to be a problem because we've got tens of thousands of other customers that are also using our network. And in order to figure out how many routers we need to have, what type of links we need to have some predictability here as far as what's going through our network. And if all of our customers are agreeing to one thing, but actually doing something else, that's going to be hard to maintain satisfaction with all of our customers. So on the ISP side, they will do what's called policing. In other words, they will measure your traffic as it's coming in to them. And if you've agreed to a committed information rate of, let's say, 50 megabits per second or whatever it is that you want, they will have a policer set up that's monitoring that rate. As long as you send them traffic that is up to but not including 50 megs, if you stay beneath that rate, you're good. They'll allow your traffic through, they won't change it in any way, and you're happy as a clam. Now, if you start sending them traffic that's above that, what does the policer do? Well, that is considered what's called non-conforming traffic. And policers can do one of two things. Usually what they do is they drop the traffic. They say, hey, look, we're billing you $100 a month based on the agreement that we would do 50 megabits per second, and you're going above that. So chances are very likely their policer will say, hey, any traffic you send us inbound that's more than 50 megs, kill it, it's done, dead on arrival. Now, an alternative action they could do is mark down the traffic. So for example, if the traffic you're sending them has some DSCP, some non-default DSCP or IP precedence value, because normally the defaults are 0, and you can't mark it down into a negative number. That's the lowest you can get. But if you were sending into the ISP traffic with higher than 0, their policer could take that traffic above the rate, let it go through, but just mark it down to 0 again, basically negating the priority of your traffic. Chances are they're probably not going to do that. They're just going to kill it. But a policer can do either or of those things. Now, what about from you? You're the customer on your end, like this says here. You don't want your traffic dropped. So let's say that I'm the customer router and I'm facing you. You are the ISP, I'm the customer. Now in the back of my head here, I'm getting traffic hitting me at like 55 megabits per second, trying to go to the internet. And I think, uh-oh, okay, let's see here. We've got a committed information rate of 50 megs. That's all I can send to you, but what I'm getting inbound is more than that. It's 55 megabits per second. Well, certainly I could police as well, but from my perspective, all of my traffic is important. I think it is anyway. I think everything's important. I don't want to drop anything. So on my side, I could implement another quality of service feature called traffic shaping. What traffic shaping says, it says, okay, here's what I'm going to do. Hopefully, this traffic that's coming in at 55 megabits per second is just temporary. In other words, it's just a little glitch in time where it's like, boop, really far, really high, and it's not like consistently coming in that fast. So if just for a few moments, a few seconds, traffic is hitting me on the back of the head at 55 megabits per second, here's what I can do. I will play it out to you, the ISP, at our negotiated rate of 50 megabits per second. What am I going to do with the excess traffic? I'll buffer it. I'll hold on to it in memory, I'll delay it, and then I'll play it out when I can, as long as I don't go above 50 megabits per second. So that's what's called traffic shaping, is where it might be coming in at this rate, fast, slow, but it's going out at a consistent rate, and that's what the traffic shaper does. It says, okay, any excess traffic, I'll just hold it back, and then I'll play it out again when I can. So shaping is typically done on the egress interface leading to the ISP. So hopefully now you have a good idea as to what the differences are between policing and shaping. Both of them set a threshold, both of them set some level, they start monitoring traffic either inbound or outbound. But what the difference is what they do to the traffic that goes above that threshold. Policing typically says, you're dead. Any traffic above that level, kill it, don't deal with it. Traffic shaping says, okay, any traffic above that level, I'm just going to set it aside, and then I'll play it out again later when I can. Now this here is an example of a policing command, one of several you could do in a Cisco router. And my purpose here is not to go over how to configure this, but I just want to draw your attention to a little bit about how this works. Like for example, we are matching some traffic, and the class of the traffic, we've just given it a name of press 3. Probably traffic with an IP precedence of 3 would be my guess, but that's just a descriptive name, press 3. That could be anything. But the point is, We're matching a class of traffic. Now what we're going to do is we're going to monitor that traffic with a policer. So the policer, we say, okay, what is the committed information rate? Let's say it was 50,000 bits per second, okay? With a peak information rate of 75,000. All right, so what does this mean? That means, okay, so let's do it like this. So my peak is 75,000 bits per second, and then I got another level just below that, which is 50,000 bits per second. Okay, so this is what my policer is monitoring. Now here's what the policer is going to do. Conform action. What does that mean? That means for all this traffic, all the traffic that is below 50,000 bits per second. And that's just an example number. So what am I going to do with that traffic? Well, typically you would just transmit it. Just let it go through. Don't touch it. Don't mess around with it. Okay? What about the traffic that falls in this area right here? So it is exceeding my committed information rate, but it has not reached yet my peak information rate. Well, that is my exceed action. In this case, I'm saying, okay, let's set the precedence to 0 and transmit it. So between these two lines, we'll still let it go out, but if that traffic came in with some non-zero precedence level or non-zero DSCP level, we're just going to set it back to the default of 0, and then we're going to send it out. Now, what about traffic that is above this line right here? Well, that is above my peak information rate. Now that's my violate action. I am dropping it. So you can see this particular policer is doing two actions in one. For some traffic, it's completely killing it. It's dropping it. For other traffic, it's allowing it through, but just marking it down. So that's just an example configuration of how a policer could work. As far as traffic shaping is concerned, okay, so just a little comparison here. Like it says here, policers can be applied on ingress or egress. In other words, for traffic being received or traffic we're about to transmit out. Usually it's done on the ingress. And like I said, typically ISPs will use policers, and you, the customer, will use a shaper on the egress side. Most Cisco switches do not support traffic shaping. Just a little caveat right there. And I want to conclude this video with just a sample configuration of traffic shaping. Like we did traffic policing, here is traffic shaping. So without going too much into the details here, once again, we're matching on some class of traffic. This time it's got a different name, press 0. And this time we're applying traffic shaping to it. And we can say shape average in bits per second. So in my previous example, if the ISP and myself had negotiated a committed information rate of 50 megabits per second, I could say shape average 50,000. That'd be in bits per second. Or you see here, I can also add these things if I wanted to. So instead I could say shape average 50M. And because this is using the shape command, anything that hits this egress interface that's faster than that will be buffered, and this interface will only send out traffic at up to 50 megabits per second. So that concludes this video on the differences between traffic shaping, policing, and markdown. Thank you for watching.